Hello again. We're going to take a look at problem 6 now. And there's actually something called the law of the unconscious statistician. That's for real. And we're going to use that to exploit the fact that if I have the expected value of f of x, that's the same as the summation of f of x times probability of x. Or in the case of the continuous random variable, it's actually the integral of f of x times p of x. Okay, so for this one, we have the expected value of 1 over x plus 1. And what you're going to do is just plug in that value at the beginning of the distribution. So I have 1 over x plus 1 times my regular binomial formula. So it's n choose x of p of x times 1 minus p to the n minus x power. Okay? Now, because of our definition of factorials, I can write this as n factorial over x plus 1 factorial times n minus x factorial times p of x times 1 minus p to the n minus x. And so I'm going to rewrite that. And what I'm going to do is multiply top and bottom by n plus 1 times p over n plus 1 times p. And the reason I'm doing that is so I can get the n plus 1 factorial in the numerator here. So I pull 1 over n plus 1 times p out. I have n plus 1 factorial over x plus 1 factorial times n minus x factorial times p to the x plus 1 power times 1 minus p to the n minus x. Okay. Now we're going to go back and use our nice little substitutions the same way we've been doing. And I have y is equal to x plus 1 or x is equal to y minus 1. M is equal to n plus 1 or n is equal to m minus 1. So I still have my fraction sitting out in the front. I have the summation of y minus 1 through equal to 0 through y minus 1 is equal to m minus 1 of m factorial over y factorial times m minus y times p to the y times 1 minus p to the m minus y power. Now, when I rewrite that, I notice my limits of summation go from 1 to m. So I need to have the part where y is equal to 0. So how am I going to get that? Well, I'll have m factorial over 0 factorial times m minus 0 factorial. So that leading term goes to 1. P to the 0 power is just 1. And then I have 1 minus p to the m minus 0 power, or 1 minus p to the m. Or if you go back into the definitions, it's 1 minus p to the n, 1 minus p to the n plus 1 power. So if I were to add that in there, this whole thing would go to 1. But I don't have that directly. So I can write my leading fraction and then the grand total of 1 and then subtract out that value when y is equal to 0, which is 1 minus p to the n plus 1 power. And that's how you do it. And again, that's one of those sneaky things that you have to do a couple times. That's not intuitively obvious. Okay? Hope that helps.